Let's learn about double and half angle identities. We're going to derive both of those, and we'll look at examples of each. You can have your notes in pencil and your trig identity sheet ready. So first off, what is a double angle? If our angle is theta and we want 2 times that angle, it becomes sine of 2 theta. So not sine squared of theta, that's sine times sine. This is sine of the double angle. Some tips: make sure you're drawing your triangle in the correct quadrant so that you can think about the plus minus, and that will help you. So if you're going on the left of the x-axis, x is negative and y is negative, and thinking about where your sines and cosines are positive is going to help you get the correct answer. So we're going to derive the sine of the double angle formula. And if I'm doing the sine of 2 theta, that really means I'm doing the sine of a theta plus a theta. So then I can use the sum of the sine to do this. So remember, with sum of the sine formula, it goes sine, cosine, cosine, sine. And if it's addition, it stays addition. So this becomes sine theta, cosine theta, plus, switch it around, cosine theta, sine theta. Well, multiplication you can do in any order, so even though those are switched around, they're still the same thing. So sine of the double angle is 2 sine theta cosine theta. And that's our identity for sine of the double. Let's look at cosine of the double. And there's going to be a few variations that we can use. So we'll go back to the beginning and we'll start with cosine of theta plus theta. Remember, with cosine, cosine stays together, sine stays together. Addition becomes subtraction. So I'm going to have cosine theta minus sine theta sine theta. Well, cosine times cosine is cosine squared. So one identity that we have is cosine of the double angle is cosine squared theta minus sine squared theta. That's the one that I usually use the most, but you can substitute in Pythagorean identities, manipulate it around. And so if I look at cosine squared, that is the same as 1 minus sine squared. So I could substitute that identity in and then finish it minus sine squared, combine like terms. And another double identity for the cosine is 1 minus 2 sine squared theta. You can use that if you're dealing with sine. And then if I go back to the original one, and instead of substituting in for cosine, I substitute in for sine, we can do that. Just be careful with the subtraction. So we have cosine squared theta minus sine squared theta is 1 minus cosine squared theta. I'm going to distribute that negative, so we get the cosine of the double angle could also be cosine squared theta minus 1 plus cosine squared when I distribute that negative. So I have 2 of those. So cosine of the double is 2 cosine squared theta minus 1. And I use that one when I have some cosine. Let's look at tangent of the double. So we're going to say that is the same as tan of theta plus theta. So that's our sum identity. Well, that says in the numerator, you're just going to add them. Tan theta plus tan theta. In the denominator, you're going to do 1 minus those 2 things multiplied together. And then we can simplify it up. So in my numerator, I have 2 tangents. In my denominator, I have 1 minus tan squared. And that's my identity for tan of the double angle. Let's look at this example. We're asked to find the sine of the double angle. We're given some information. I'm told that it's between 0 and pi over 2, so I know I'm in the first quadrant. So I'm going to draw my reference triangle there and put theta in the correct spot. I'm given sine of theta equals 2 over 3. So that means that opposite is 2. My hypotenuse is 3. I need to figure out the x value, so I'll do a quick Pythagorean theorem. Plus 4, 9, so it's 5, take the square root. So that's going to be the square root of 5. So we're going to use that because we are going to be using cosine. So sine of the double is 2 sine theta cosine theta. So plug in your sine, which is 2/3. Plug in your cosine, which is root 5 over 3. And then multiply. So across the top, I have 4 root 5. And the denominator, don't forget to multiply them. You get 9. So your answer there is 4 root 5 over 9. Now, if I'm thinking about the double angle and I kind of draw it like that, I don't know if the double angle, if it's going to end up in the first quadrant or if it were bigger and then it ends up in the second quadrant, because I did get sine to be positive, but sine is still positive in the second quadrant. We'll see what's going to happen with cosine. So cosine of the double angle with the same triangle. So we're looking at 2 and a root 5 and a 3. I'm going to use the first identity that we did. So I'm going to say cosine of the double angle is cosine squared minus sine squared. I'm going to plug in my cosine squared, which is, cosine, root 5 over 3 whole thing squared minus 2/3 squared. That becomes 5 over 9 minus 4 over 9. So cosine of the double is 1/9. Well, it's positive, so I know that I must have had an angle less than 45 because I can get a double angle in and it stays in quadrant 1 and it doesn't go to quadrant 2 where cosine is negative. If it did, then this cosine would have come out to be negative. And tangent, same triangle. Let's just work through the formula. So we have this and tangent of the double angle. So we're going to say, I'm going to do 2 times 2 root 5, square root of 5, all over 1 minus 2 over root 5 whole thing squared. So be careful, lots of radicals. So I'm going to have 4 over root 5. In my denominator, I'm going to get a common denominator. When I square this, I'm going to get 5. So this will be 5 over 5 minus 4 over 5, which is 4 root 5 over 1 over 5. Now here, please do not just on this, like tack this on and multiply by the reciprocal. It's the next step. So it becomes 4 over root 5 times the reciprocal, which is 5 over 1. So that's 20 over root 5. I'm going to rationalize it and multiply the top and the bottom by root 5. So I get 20 root 5 over 5, which is 4 root 5. Let's switch to the half angles, and this time we're going to start with cosine. So let's see. Yeah, cosine. So I'm going to write out the first one. So not the first one. Cosine of 2x equals 2 cosine squared x. I think it was the second one we did, or the third one. And I want you to solve for cosine squared. Well, I'm just going to switch the sides around. I just like to have whatever I'm solving for on the left. And now we're going to undo the algebra. So I'm going to add the 1. And the formula has it written in front. So we have 1 plus cosine of the double angle. And then I divide by 2. And then I take the square root. And remember, when we take the square root, we need to have the plus or minus 1 plus cosine of 2x over 2. So a couple of things that are interesting and that we need to remember with these formulas. We have this plus minus. You have to choose, depending on where your triangle is, what quadrant it is, what it's going to come out to be. Just because you plug in the correct cosine sign, the math is not going to work out. So you need to figure out where the triangle is in order to choose if it's going to be plus or minus. It's not going to be both. The other thing you notice is here we have cosine of 2x. We are going to use u substitution. So we're going to say let u equal 2x. And then if I solve for x, that means I'm going to divide by 2. So x is u over 2. So what that means is I'm going to plug that in there. So now I have cosine of the half angle equals plus or minus the square root of 1 plus cosine of u over 2. And that's how the formula is written. That's how you'll see it on your sheet. And we'll do some examples to see what that looks like. Let's derive the sine formula. So I'm going to start with cosine of the double again equals 1 minus 2 sine squared x. I'm going to solve for sine squared. I don't have to flip it this time because it's already negative 2. So I'm going to add it over. Becomes positive. I'm trying to get it by itself, so I'm going to subtract the cosine. Divide by 2. take the square root, and then we have that. So it's the same thing we just dealt with. You're going to have to decide if it's plus or minus. We're going to use a u here, which then means we have half angle here. So half angle is sine of u over 2 equals plus or minus, but not both, 1 minus the cosine of u over 2. It's almost exactly like what we just did, except sine has the subtraction in it. I'm not going to derive the tangent for you, but we have the tangent of the half angle is plus or minus. We have to decide. And then it's the square root. It's a big square root of a fraction. So it's 1 minus the cosine of u over 1 plus the cosine of u. So tips with half angle identities is you use the u substitution. So that means we're going to double the angle, which feels a little weird. It feels like we're going in the wrong direction, but we have to double the angle in order to get to half the angle. So if I'm trying to find the sine of 15, that means I want to use 30. And what I mean by that, so I'm going to write it as sine of 30 over 2, because that is 15. But now this is the 30 is what I'm plugging in. So I know from sine 15 that I'm going to be in the first quadrant. So I know that I'm going to have the positive square root, not the negative. And then we do 1 minus the cosine of 30, not 15, divided by 2. So we have the square root of 1 minus, well, the cosine of 30 is my small triangle, so that's my root 3 over 2, all over 2. And then I have to get a common denominator. So in my numerator, that 1, I'm going to change it to 2 over 2. So it becomes 2 minus root 3, all over 2, all over another 2, all under the square root. Here, don't multiply by the reciprocal. It's going to be the next step. So we have 2 minus root 3 divided by 2 times the reciprocal of 1, which is 1/2. And then I get the big square root of 2 minus root 3 all over 4. I can take the square root of the denominator and I get just the square root on the numerator now, 2 minus root 3 all over 2. That's my final answer. I don't have a radical in the denominator. I know I've gone far enough, and you are going to see radicals within radicals on these. So there's your formulas. You'll have your identity sheet, and we'll be practicing how to use them further. There's your half identities, and we did it. Good job.